problem that bridges present worth and annual worth, because you can do it either way, but it does illustrate some of the strengths of annual worth and some of the weaknesses with present worth. Present worth, you're going to find out, is really great for problems that have delay in them, but they have difficulties with some kind of repeated or cyclical kind of investments, while annual worth is better with some of the cyclical stuff. This problem actually stems from a project that I was considering doing in my backyard. It was my backyard aquaculture idea, and the idea I had was I was going to create a tank that had fish in it in my backyard. I was thinking about tilapia, and the idea is I could take my kitchen waste, throw it in there, the fish could eat the kitchen waste, and they would poop, and I could stick that in my garden, and I could still eat the fish. So I was adding this extra cycle in there. In order to get this to work, I was, however, going to need a little bit of pumping, and so the pumping part actually ended up being the investment choice. And so I had two choices for my pumps. I had what I'm going to call pump style A. It's right here. Pump style A cost $100. And after 3 years, what happened is that I could go ahead and salvage this pump out and get myself $50, and that's salvage value. Pump B was something that cost me $250. Lasted 5 years, and I could actually sell this guy for $150, the remainders. So these were my two pumping options that were there. Now what's interesting about this is that because we're dealing with these repeated purchases, we have to make sure that we're still providing the same amount of service in each case. And we also have to sort out what a planning horizon on this is supposed to be. And one of your common choices for planning horizon is that you choose the least common multiple of these two asset lives right here and say, well, here's how long I'm going to keep things. In this case, we're talking about 15 years. Now, for me on a project, 15 years is reasonable. It's something you suppose I can do it because, yes, I do like to garden. Yes, I do like to do all that fun stuff. So this is actually kind of reasonable. If these were numbers like 9 and 10 or something along those lines, a 90-year planning horizon isn't a good idea for me. In 90 years, I should be dead several decades, so it's not the perfect response right there. But we are going to follow that very general rule of just choosing least common multiple. And what that's going to do is going to make it so that we don't have to worry about salvaging one of these items early. So let's go ahead and give our 15-year planning horizon. And what we have to note is that in order to figure out what the best option is, we can't just take the present worth of these assets and then say, well, this one has the present worth that's closest to positive infinity, because while these may be fine assets, they're not providing us with the 15 years worth of service. And so we have to think about is that there's going to be this repeating cycle of purchases that we're going to make. So to illustrate what the cash flow diagrams will look like, we're looking at, in this case, purchasing for $250, one of these assets in time period 0. Then what we're doing is, in year 5, we're salvaging it out. At the same time, purchasing another one for $250. Then, after 5 more years, getting us up to time period 10, salvaging the one that we purchased in time period 5 out, and getting another one for $250. And then going ahead and buying another one, which we then salvage out in year 15. And so what we're doing is we're making 3 purchases of these assets, one after another, in order to provide us with our full 15 years of pumping service. So it's this whole sequence right here is actually the investment that we're evaluating. Not the single purchase over here, but the sequence of 3 purchases over time. And we're doing something similar up here with asset A. Here it is that we're purchasing it for $100 in time period 0. Then in time period 3, we're salvaging it, buying another one. Then in time period 6, we're salvaging it, we're buying another one. Then in time period 9, we're salvaging it, we're buying another one. Then in time period 12, we're salvaging it, and we're buying another one. And then in time period 15, we're salvaging it out. And so again, the investment we're evaluating is this whole stream of investments right here, not this individual one. So let's go ahead and pull this together in a present worth fashion before we start looking at it in an annual worth fashion. And our first step is going to be to calculate the present worth of just one of these assets right here. And choosing kind of a nice interest rate. The interest rate that we're going to use is 8%. So let's replace these two parts here with our calculations. So the present worth of a single asset A purchase should be the initial $100 cost. And then what we're going to do is we're going to get our salvage of $50, which is going to be 3 years out in the future. And we're going to keep an interest rate of 8% on this. So it's 1 plus 0.08 to the third. And that'll give us the salvage value, sorry, the present worth of a single purchase and sale cycle. So it's just this little chunk right in here. And that's actually going to equal to $60.31. This part over here, the present worth of a single purchase and sale cycle of asset B, is negative $250. That's our original purchase. And then we have this 150 salvage. Divide by 1 plus 0.08, 1 plus the interest rate, raised to the power of 5. And that's going to give us the present worth of a purchase and sale of a single one of these Pump B stuff. And that's negative $147.99. So now we have the present worth of a single purchase. Well, what we have to do then is figure out how to take those values and connect them with these full investments that we're evaluating, each one of them providing 15 years of service. And that's usually the key phrase that I'll use when I'm talking about these kinds of repeated purchases. So in order to keep things fairly simple, what we're going to do is use this calculation right here, noting that what this does is it takes all this value that's scattered over year 0 and year 5, and it concentrates it in time period 0. So what you can think about it as, what it's doing is it's saying, take these values and turn them into a present worth of B. And then it takes all these values here, and it turns it into a present worth of B. And it takes all these values here, and turns it into a present worth of B. So in order to make that calculation on this full 15 years of service, all we have to do is take the present worth of B, and then say, well, we have this other thing that we have a present worth of B, but we're going to have this purchase in time period 5, and we have another present worth of B, and we're going to make this purchase in time period 10. So if we replace each one of these present worth of B with that 157.91, what we're going to do is we're going to find out that the cost of providing 15 years worth of pumping service with assets of type B is $137.09. Now, the upper problem is a little bit longer, but essentially all that we're doing is taking present worth of A, that first purchase, then doing it again for the second purchase in time period 3, then again for the third purchase in time period 6, then again for the purchase in time period 9, and again for the purchase in time period 12. What you're going to find out is that the cost of providing 15 years worth of service with this kind of pump is $210.37. So clearly, if you're dealing with the present worth criteria, Pump A is the way to go.